Okay, it's my very great pleasure to introduce to you our next talk. I think industrial security has been in the news a lot in the last year, and I'm very curious what our next speakers are going to have to say about that, and especially in the context of railways. So please welcome Sergey, Alex, and Gleb with the next talk, The Great Train Cyber Robbery.
Hello, Congress. It's a great pleasure to see you again. As usual, we only frontmen for SCADA Strangelove team who, for last 5 years, trying to save humanity from industrial disaster and to keep purity of essence. So please keep your big hands for all people who support us. Just not for journalists, this is SCADA Strangelove team talk, and mistake by joke all our responsibilities. It's not related to our employers. So, railways. Railways is one of the biggest artificial systems built by humanity. It takes thousands and thousands of kilometers all around the globe on different continents. And my personal trip, railroad trip, when I was a student, take more than 9,000 of kilometers and 6 days. Maybe because I was young and have a lot of time, but still, even now, I prefer to travel by train because on airplanes you see the Earth from the skies. When you're in train, you can observe, connect with people with this land. But in our hacker vision, most important question is how it's work, because it's always interesting to understand how work, in this case, railways. There are two important words in railway universe. It's signals and switches. Signals allow to train operator, to train driver to understand correct speed. Should he speed up or stop or slow down? And switches obviously allow to change direction and move train from one track to another. Many years ago, switches and signals operated by human manually. So if you want to move train in different direction, you must change switch by your hands. But about maybe 100 years ago, modern system, call it interlocking, was invented. Interlocking is a system which calculate dependencies between train location, signals, and switches position to understand can train go in this direction or is prohibited. So if it see conflict routes when train can collide, it's prohibited this situation by at first physical locks. That is why it's interlocking. It looks like steampunk picture, but still physical interlocking works. For instance, in New York City Transit, you can find what some of stations still operated by manual interlocking machine. Very important point related to railway is a way to understand position of the train. There are a lot of different ways to do it now in modern world with all this high-speed train. There are GPS tracking, GLONASS tracking, but track circuits still very widely adopted. What is a track circuit? In this idea, we use rails as wires and transfer power into rails. Sometimes it's DC, sometimes it's AC with modulation. By the way, signal relay accepts this signal, and if it's okay, it's open to clear light to green. If we have a train on the rails, when it's kind of little short circuit, and relay is de-energized, and the train switches to stop signal. So now we're speaking about relays. After physical interlocking, most of railway automation system was built on the relays, on special Vito relays, which built with a lot of gold, which can operate in wide range of temperatures. And what's most important, Vito relays are gravity-operated devices. But nobody knows what is gravity, which is why I think nobody knows how Vito relays are working, and it's working by magic, and that is why we should trust it. By the way, for me, relay room on railway station is a place where students are about and get inspiration for their soundtrack, because you can sit here for hours and listen to this music. Okay, this is old school, but today things changed, and we have a lot of automation system, computer-based system on the locomotive, on the way station, on the station, on wayside. It's a traction motor control, computer-based interlocking, computerized ticketing system, etc., etc., etc. Let's discuss in details how it works. I want to give you an example about Eurostar train, which named it one of the most smart train in the world, because it have 7 automated systems on the board for France, for Great Britain, for Belgium, and generic European train control system. But let's stop for a second and check this highlighted reactor protection system on the board of Eurostar train. I hope this is typo, because I am not ready to speak about nuclear train at the moment.
Hello. Hello? Can you switch on the mic? Yep. Hello. So the locomotives, they built from several vital systems, like the one that allow them to move, to stop, to say the driver about the situation on the road, and most importantly, the train protection system that can somehow react and prevent some accidents. All these subsystems are interconnected. So, for example, traction system won't mess with braking, or in case of some accident, the train protection can stop the train. The bummer is you can't find anything to conduct security research on the internet, publicly available. And this is true for all railroad software. But if you try hard enough, so let's speak, for example, about one system that's actually a train protection system called CBus. The 10-year-old version of it, CBus 32, is very, very widespread, and the newer one is CBus PN, is very new and is still a catch, and some of us will catch it more than others. So let's look at on how this system was updated, and just by looking at it, we can see a lot of things, like they stopped using some proprietary operating system, and it's a good news, because most of the time home-brew operating systems tend to be disastrous. In this system, they don't have hardware controllers. They have PC-based emulation called WinAC RTX. They have new modern, well, not new, not modern, but unified transport like Profinet. And nowadays they use very widespread CPU architectures like x86 and PowerPC. And it's a way to ease the job done by reverse engineers. So when you read a lot of manuals and documents on the internet, and you know from which subsystems some locomotive components are built, you can actually, or probably, find something on the internet. We are speaking about WinAC RTX PC-based controllers. But it's not the time to talk about it. But still, we can talk about the internals of the system, and this is actually what tells us a lot of things, not vulnerabilities, but weaknesses. Like if you want to control the controller, to stop it, to shut down, to run, or anything else, you don't need authentication, and you don't see any kind of industrial protocols. It's just XML over HTTP. And it's easy to repeat and easy to build your own tools to control them. And if you look deeper, all these things are self-written, like HTTP server and XML parsers, and I believe you can guess what this means. The next logical step would be to talk about how can we reach those systems in real world. But we don't know, and we don't want anybody to know about this.
So let's continue our saga and switch to computer-based interlocking. The goal of computer-based interlocking is to help to manage route through the station, and if we try to analyze it from as a computer system, we can find following important part of computer-based interlocking is a Yardmaster workstation. It's like a human-machine interface. In ICS environment, it's just a PC with special software on the top. And the second important part, this is integration gateways. Which helps to connect sometimes wirelessly to different station or to centralized traffic control system. Most important part of computer-based interlocking is a central processing unit, which process all dependencies, like we saw in the previous pictures with logs. Now it's processed by computers. And object controllers, like PLCs in our SCADA environment, which transfer management command directly to wayside devices to switch the switch or to change the light of the of the light. Requirements for computer-based interlocking is very formal. And in different countries, you can find these requirements as a state law or as a law of different railways companies. By the way, because it's vital component of, for safety, for traffic safety, this requirement is fixed, and all interlocking system must must fit such requirements. Sorry. When we speaking about security, it's very important to build correct threat model. Because you know, when we discuss computer security, people mostly discuss integrity, availability, confidentiality on information, but this does not work in industrial world. It does not work for computer-based interlocking. From our point of view, there are 3 levels of threats. First level, related to safety or cyber-physical threats, allows to attacker to create a disaster. Second level it's economical threats which allow to attackers to impact freight efficiency, to to impact your revenue as a railroad company. And low level is reliability, when you can impact system, but this just add additional work for engineers who support this system. Sometimes colleagues asking me what is cyber physical threats. For me, I don't have a clear definition, but for me, the threats which can be done in cyber world, but impact something in real environment, like this. Always funny on the pictures in the Twitter, but let me explain by example what is conflict routes or what is a less restrictive signal light. This is example of conflict route. This is less restrictive signal light. But this is Lego toys. Let's check it, how it works in real life. It's not such funny. So, switching is in correct position, and even if driver understands the situation in trying to stop, it's impossible because train very heavy. So let's discuss attack vectors, again computer-based interlocking to make appropriate model. First level, it's attacks again workstation, which can be easily accomplished by security, physical security bypass, or by social engineering, because it's not very hard to force somebody to plug USB drive into workstation. Second level of attack, it's attacks against integration gateways, against wireless and wired network devices, which connects computer-based interlocking to rest of the world. And other attack vectors also related to communication between yardmaster workstation and CPU, communication between CPU and object controllers, and sometimes even related to communication between object controller and wayside devices, because we saw a situation when object controllers communicate with wayside devices over wireless link. So if you can intercept it or make a man-in-the-middle attack, you can control switches by yourself. So I will give you several examples. All examples are from Google. It's not related for any particular assessment we did in the past. First, physical security. It's actual pictures, I guess, and it looks like actual pictures because during our assessment, physical security is terrible. In most cases, you can say, okay, guys, I need to check your system ABC XYZ, pass to the station, and get access to workstation or a service. Password protection. Second picture from movie, documentary movie about Great Britain railway automation system. The main challenge here to guess workstation name, which also a login. This is COVSX something, but I think NetBIOS responses can help here. All software, it's everywhere. It's again from Google. It's actual new equipment and system approval certificate, which allows to use system which runs on the Windows NT 4 Service Pack 6 and above. And this system manages track guards, and this is flexible safety processor. But about safety, most of railway system built with redundancy in mind. It's used several CPUs, sometimes 3, sometimes 4, sometimes even 8, which runs different, same, but the different programs, sometimes built by different team of engineers. And some kind of majority system which compare results and trying to understand is there any problem with computation. But in practice, it means if you have a root access to computer-based interlocking, you need to patch several locations in memory, not only one.
Hello again. So as Sergey said, previously in old days we had this steampunk-like interlocking, most of the complexity of building them was in crafting of building, and nowadays it's about how to create a safe system. So by saying we want to have a safe interlocking, we mean 3 things, like trains should not collide, should not derail, or trains should not hit people. And they are doing this by use of different formal methods, so to mathematically prove that these safety critical systems are really safe. I won't tell you about formal methods. This is a topic for a separate talk. But in short, we are talking about creating a set of specifications with requirements and a model of our process. And the point is to prove that our model satisfies these requirements. We have the world have a lot of different instruments like P-method, event B, ProverCom, and so on. And all of those systems are used by industrial companies to make safety critical systems. And we will talk about B-method that is very widespread, not only for, I don't know, space rockets, airplanes, and trains, but also for vending machines and traffic lights. There is a development environment called Atelier B that allows us to create those specifications and models, and later on to prove that we are safe. This development environment also have translators from the models that you have created to different languages like C, C++, and others, so you can later integrate them into your solution. We are not trying to say here that the math is wrong with Atelier B or the B method itself, but we're trying to show how a human developer can create wrong specifications, and this can create different vulnerabilities like memory management. And this is a part of slides from one of the developer of Atelier B, where they say that they can cope with all of those problems. We took Atelier B and created a very small project. It's called bed index. It has an array and one operation that tries to access an item in the array. And as you can see, there is no boundary checking in the code, and all of the green circles to the left, they say that all type checking was done correctly, that we generated proof obligations, we proved everything, so kind of we are safe. So if we generate a program in C afterwards, we can see a situation where a memory corruption or segmentation fault can occur. And again, this is not the fault of the math, it's a fault that we haven't done the boundary checking. And the point we want to prove is that they're still humans, the people who write these specification requirements. And as with any other programming language, they can introduce vulnerabilities. Actually, good news, in the world, none of the people I heard that generate these things to C code or C++ code, they use ADA, which is, with its strong tag checking is a more secure language in comparison to C, for example. But there are some pitfalls too, like typical ADA implementations have a mechanism called trampolines, and that means it will execute code on stack, which is not very good for C programs. And for example, if you want to link other code with C libraries, one of the security mechanisms won't work. So let's get back to the railroads, to the interlocking. These systems are not actually that easy, and most of the times people who create those formal methods, they try to mathematically prove that only the logic part is safe. Like Sergey said, we must not allow trains to collide or something like this. All other systems, like the operating system where we will place our code, the different communication services, the user interaction part, the part with the signaling when we want to know where is the train, what is the position of the switch, and so on. It's almost always written in C, and this provides us a lot of capabilities to exploit this and somehow to influence this proved for safety logic and to create it to work otherwise. So this is a slide where we show the vulnerabilities for these formal methods and other vulnerabilities of these interlocking systems. Thank you.
But if you're trying to discuss those vulnerabilities with railway people, with engineers, with people who support interlocking system, the typical answer, okay, you can create conflict rules, but in the lab, because all in real life is air-gapped. Okay, let's talk a bit about air gaps. Fortunately, if you type railway in Shodan, you will get very few results, and most of those results is false positive, I hope. But sometimes you can get something interesting. For instance, Delhi railway station somewhere in India, which accessible via PPTP port. But I guess this is not something industrial grade, it's just internet access for station. What's interesting here, interesting that this device is located in the company Railtel Corporation of India. So I guess that there are special telecom operators for railways. For instance, in Germany, there is special network operator who support Deutsche Bahn network, and also they provide SIM cards. Interesting, why railway operator needs SIM cards? To allow train drivers to upload high resolution video to YouTube or something. No, for GSMR, GSMR is a railway version of GSM, which use it to connect trains to wayside devices, to calculate optimal speed, to understand train location, to manage all conflict situation. And GSMR is good from encryption point of view. It was a very good talk from Stefan on 28C3, and you can find a lot of information about GSMR key change, encryption there, and we decide to don't go this way, to don't crack encryption. We decide to check other side of GSMR. For instance, jamming. So it's in specification that if digital modem, the digital modem on the train should always be connected to control center. So if the modem connection is lost, the train will automatically stop. So if you have a good GSM jammer, but on different frequencies, you can stop a train if you need it, or you can go in jail also, if you need it. There are different other interesting issues. For instance, in GSMR handset, there is a very useful feature to manage this handset via SMS with password 1234. I'm not sure, but there are a lot of engineers who changed this password. I guess there are not so many engineers who even know that this handset can be managed via SMSs. To continue SMS discussion, there are very interesting feature in GSMR SIM card, which call it over-the-air management, and which absolutely the same like is in our standard SIM cards. I know that you know that SIM cards can be hacked over the air. It was discussed several times by Karsten Noll, by Alexander Zaitsev and Alexei Osipov. And if developer of SIM card applet have some issues with programming, he can allow you to get encrypted response to brute force signature key, and after it receive information about encryption key, and sometimes even upload malware on the SIM card. After Karsten talk, many of big telecom operators decide to review SIM cards or filter binary over-the-air SMS messages, but I'm not sure that something similar going in GSMR world. Moreover, some GSMR equipment supports over-the-air firmware updates, not only SIM cards updates, which allows you to do firmware updates over the air. Modern modems for GSMR supports interfaces like USB or PCMCI, which reminds me our old research, which named it Bootkit via SMS, when was demonstrated like how attacker who can hack the modem over the air, for instance with over-the-air firmware update, can use it to hack the host which use this modem for network communication and gain control over this host. This is old video, it's online for a year, which demonstrate how hacked modem, which connected to laptop, first starts to work as a modem, network devices, and this is okay. But after a short timeout, it starts to operate as a keyboard. And obviously, keyboard can type. So as a real hackers, our modem start calculator. And after we get a specification of input-output system to bypass safe boot, safe BIOS if you have it, and reboot the computer. During reboot, our modem become a CD-ROM drive. And install bootkits. You can ask me, are there any keyboards in railway equipment? My answer, sometimes they have it, sometimes doesn't have, but in most cases, they have drivers for keyboards, drivers for additional system for printers sometimes. And if you can become a printer or camera, you can exploit vulnerabilities in drivers or direct memory access, as was demonstrated by Travis Goodspeed and Sergey Bratus for local vulnerabilities, and as was demonstrated by Timur Yunusov and Kirill Nesterov for remote vulnerabilities. Because nobody cares about buffer overflow in keyboard or mouse driver. Why? Because it cannot be exploited remotely. But if your remote device can become a mice and exploit this vulnerability, you can exploit such vulnerability remotely. So let's back to railway system. And if somebody can attack the modem can attack automatic train control system, and you can control the train.
Well. Everything is interconnected because everything is entertainment. Well, let's take a look on the locomotive railway systems, and you can find out a lot of devices, a lot of systems. From one point of view, it's especially for passengers, users, like information entertainment systems. Another one, it's devices like intercommunication between engineers, cameras, wireless access points, gateways, and so on. But the main idea that all of them operates through the one communication channel. One of them communicates especially for railways, another one for some kind of information systems. Well, and it's another one proofs of it because, no, it's for example, from big vendor Mocha. And it shows their approach how to get connected different devices and how they connected with locomotive, especially for solar power plants and AP cameras too. And they tend to fly in the clouds. And nowadays, modern way, they tend to be like an Internet of Things devices. But in this case, and especially in context of our topic, it's realized, it's created without a very strong, very secure approach. Well, and we will show you why it exists. And we analyzed several vendors like Bintech, DG, NetModule, and so on. We analyzed different devices, type of devices, switches, special railway equipment, gateways, modems, and so on. And we found out a big private case zoo. From our previous experience, it exists, and it exists in different industries. But in this case, it little bit shocked us because it's railways. I mean, and there are a lot of private case, and each vendors tend to hard code the private case. Well, and well, it was not only for SSL certificates, private keys, which correlated with certificates, but also for remote management, administration, like Secure Shell. There was exist from one vendor private keys for Secure Shell. Okay, and you can ask us, and you could write, so what's the impact of it? First of all, I can say, oh, hello, Captain Obvious. If it's private and it's private became publicly available, it's not a private. It's easy, yes, and obvious. And another one, that's if you create something private, especially for private case, it's created for private communication, for private, for safe communications. But in this case, I hope you know, it's like man-in-the-middle attacks. And after it, communications between railways systems, they are not secure. Also, as I said before, it's give attackers possibility to remote login shells, and we will show you a little bit later. And another one, it's fingerprint devices. For example, you can extract public keys from private, create some kind of fingerprint using MD5 or SH1, and using search engines like Shodan or Census, you can find out a lot of devices which is connected to internet, and you know private case, you know what to do the next. And this picture shows you original, traditional way how to hold a beaver, and in this case it means how to keep your secrets. Next one is, it's again a lot of default credentials, but in case of railways management systems, it's not only for web communications, but also for Secure Shell, Telnet, and they try to change, they try to secure communications and change Telnet port, well. Another one example, it was really important notice to dear customers. So in this letter you can see that you should use only 2 possible default credentials for administrator, for the administrator password. Well, it's a dear customer was warned. Well, take a look on this piece of code. How do you think, is it secure, or is it hello from early 20s? Well, it's obviously not secure, and it's created nowadays at 2015, and it gives us possibility to inject system code. Well, next was quite interesting possibility. Everybody remember about USB, autorun, malware, and so on. But in case of railway devices, special equipment, there is exist USB port, and if you want to ease life of system engineers who don't want to go with devices, there are a lot of, you can put your USB stick and device auto start, auto run, for example, system update, software update, firmware update, or system configuration update. How it works? It works very easy, and again, it's easy life for system engineers. If you don't remember your password, you can create password list. Well, in this case, you can create password hashes, and as big as you can, and try to brute force and run your after update. Well, you can ask how it's well. Railways systems looks like isolated from the internal world, but at this picture you can see approach of attacker who can interconnect to railway station through the management system, and once said, when you connect to internet connects to you, and from the internal side of railway communication you can see that there is 3 steps. When you trace road some host, it's inside train. Next one is outside, well, it's wayside. And next one, which we mentioned before, it's telecom. Well, locomotive has a lot of equipment, And some of them works for user interface, some of them works, well, especially for net module vendor, works on through VPN. But in this case, they, all of them works through the same public mobile network. Well, and there is a proofs by Shodan that net module, especially special devices and VPN gateways connected to the internet. Next one is net module vulnerability, which was fixed in new firmware. It was a simple request which changed administrator password, just simply agreed with EULA rules. Well, kudos goes to our colleague Semyon Rushkov. And from our experience, we should give many thanks to certs from different countries. Big thanks.
Postscriptum. Last year, we spoke about wind and solar energy, and we get a lot of feedback on our talk and decide to launch SCADA SOS project, which focused on the discovering, hunting of open smart grid devices on the internet. And we get a lot of interesting results in the different parts of the world. And we get a lot of feedback from the vendors and certs. By the way, this approach, this project, helped to remove more than 60,000 internet-connected smart grid devices, like power plant, from the internet. And several vulnerabilities was reported to vendors, to certs, several were already fixed, and I want to thank Mr. Maxim Rup who contributed to this project very much. Thank you, Max. We decided to continue open approaches, so we started a SCADA Pass project. And we going right after the talk, we're going to release the list of default and hard-coded accounts and different PLCs, SCADA, HMI, to force vendors to don't use hard-coded and default password in their system. So kudos to Oksana Andreeva who helped us to prepare this the list, and please contribute. After our previous talk, we get the comment about European power system. If somebody can take 3 gigawatts of the net for a couple of seconds, the light will go out for quite a long time. But we know that there are special devices like relay protection built on the digital substation, which built to prevent such bad situation. And we again decide to research it.
Well, we did some kind of research in digital substations protocols, and in previous conferences we released special toolkits for digital substation protocols. And this year we created, with help of iGrid guides, challenge called Digital Substation Takeover. It was implemented with Siemens, C-Protect, C-Cam, protective relays, switches, industrial switches, and so on. And but guys, in this challenge, give us the result. As you can see. Global disaster. Well, and in real digital substations we have very good, very well-known protection called protection relays to avoid this kind of cable melting. But relays also vulnerable, and during this challenge, guys find out vulnerability on Siemens Protec. It's with specially crafted packets. You can create denial of servers of relays, and in this case you can cable melt. But also during the challenge, we find out some kind of confirmation code on Siemens Protec, but Siemens doesn't publish this confirmation code on official documentation, but also Siemens says that it's not vulnerability, not hard code. With this code we can read system log. Also, we can use this for device memory introspection. Very interesting. Next.
And the last question from the previous talk was about direct marketing directive, which force wind and solar plants to be connected to central management point, not only to read current status, but also to actual shut down or reduce output, because it's required by electricity market. It's now works in Germany. Many vendors have special models for direct marketing in SCADA to support these features. But we run out of time and hope to discuss these issues next year on our upcoming talk, SCADA with Antenna. Thank you.
Some people call them terrorists. These boys have simply been misguided.
Okay, all right. Okay, perfect. So, quick reminder, if you really do need to leave, please do so as quietly as possible, and if you can, stick around for the next couple of minutes until we're completely finished. If you have questions for the three speakers, please go to one of the 6 microphones in this room, so we can all hear you.
We have special prizes for best questions.
Oh, as I hear, we also even give out prizes for the best questions, so additional, motivation to ask a great question. All right, are you lining up at mic 4? No. Okay, all right, then we'll start with a question from the internet.
All right, thanks. Have you studied anything related to the American positive train control system?
We don't know yet.
Okay, I don't know. Do you have another one? Okay, all right, then mic 4, please.
You said you looked up trains on Shodan and Census. What protocols did you find them on, and how did the results compare between the two services?
In general, sometimes you can find generic remote management protocol like HTTP, like SSH. From inside network, as Gleb showed, Profinet is heavily used, but also there are a lot of proprietary protocols which not so public.
Okay, I don't see any further questions right now. So please give a warm round of applause for our speakers. Thank you.